Good evening, my lovely 12th standard warriors. Welcome to the one-shot revision session to clear your backlogs on Gauss's Law with me, Shreyas, your physics master teacher at Vedantu going live. Hi, Surya, Archana, Shruti, Sai Shruti, also Jaddu. Welcome, Pavam. Welcome, Sanjeev. So some of you are asking, you want a new playlist for 2022? Well, I'll tell you it's very simple, but before that, let me quickly introduce myself. I am Shreyas, I'm the physics master teacher, and I also lead the physics department of JEE division at Vedantu. And I have been training kids for a very long time, and I'm really proud to say that many of my kids under my mentorship have not only got into IITs, NITs, BITS and the top-notch institutes, but also secured top 2-digit All India ranks. And that's my aim, to make sure that you enjoy physics, you learn physics conceptually, and you learn how to solve the problems in the right way. So let's begin. And before that, let me also quickly show you where you can find the playlist out here. So when you visit our channel, just hit this button, playlist, and you will see maths playlist, JEE preparation playlist, physics playlist. So when you click on the physics playlist out here, okay, you can see quickly over here there are important tips, tricks, strategy sessions, and then you have your rapid revision series as well. There are few lectures only, but there are 15 minutes videos. Pathfinder playlist. This is the playlist that has all the videos of 12th standard. Pathfinder is the name of the series. For 11th standard topics, it's called as the Nurture series. So you will see all the videos related to 11th standard which you are conducting over here. But if you want, chapter wise, it's there over here. Vectors, 1D, 2D, etc. Similarly, for 12th standard, electrostatics, Gauss law, everything. So these lectures are make sure, the one that I'm conducting now, today, is to make sure that you guys clear your backlogs and get some idea about this current topic. So after this video, you should watch the detailed class of Gauss's law. Similarly, if you have watched my electrostatics, one-shot revision series, then please watch the detailed lecture to get in-depth knowledge, and also all the kinds of different problems, mains, advanced, etc. are also being covered. Okay, yes, I'll be available, bacha, in my micro courses. There are plenty of micro courses that I'm conducting, like HC Verma problem solving. Then you have Irodo micro course, derivations micro course. So many micro courses are there. Plus, I'm launching a micro course for you. We are launching a micro course for you. Guys, are you excited? If you guys are excited, put up a yo in the chat box. And if you want to know more about me, please follow me on my Instagram handle, that's Shreyas_Vedantu. This is the weekly schedule. We are here, backlog clearance for Gauss's law. Tomorrow at 7:30, that's going to be one-shot revision for basic maths calculus for 11th standard, but you can also attend it. Advanced session on Thursday morning, and then again, current electricity backlog clearing session, one-shot session on Thursday, and then mock test questions, that's on a NEET channel, the biotonic channel. I'm going to come up on Friday morning. And again, a backlog clearing session for 11th standard on kinematics 2D. So that's the schedule tentatively for this week. And I'm pretty sure you want to get amazing marks. You want to, excel in your studies. And if you want to do that, apart from YouTube, and you want to know what is the reason why Vedantu has produced so many toppers, be it ICSE, be it CBSE, be it JEE Mains, be it JEE Advanced, every time. I mean, look at these numbers. 4 out of 5 students from Vedantu are already qualified for advance. Last year, more than, around 400, 500 students went into IITs after clearing JEE Advance. That's a huge number for a coaching institute, which is relatively new. And I'm proud to say that our teaching methodologies have played a significant role apart from the student hard work. Obviously, you cannot discount that. And you can see consistent improvement right from JEE Mains 1, 2 and the 3rd attempt. You can see there are thousands of students above 90 percentile. There are hundreds of students above 99 percentile. And all of this because of our pro subscription and the crash courses that we give you. And if you want to study under me and you want to take up the courses which I'm taking, even be it live or recorded, please check it out. The pro subscription link is there in the description box, and there is a limited sale going on, 50% off if you use the coupon code SHHPRO. So do not forget to check out the link in the description box. Alright, so have you guys smashed the like button? If you have not, please smash it right away and let's get going the revision series for Gauss's law. Alright, hi Surya, good evening. Hello Harshita, hi Vijay, hello Pawan, welcome aboard Vachalok. Let's get going. Thank you for all the love from Tamil Nadu and all the parts of India. Thank you guys. Hi Archana, hi Nandini, welcome Vijay. Alright Vijay, you have smashed it. Chalo, let's talk about flux, then we'll talk about Gauss's law, then we'll talk about uses of Gauss's law in different geometries, and then we'll end the class with different properties of conductor, and obviously we are going to do problems after every small theory topic. Okay, so that's the flow of the class today. Remember, this is one shot revision. This chapter was already covered in Pathfinder series. So what should you do after the class? After watching this video of mine, be it live or recorded, you should check out the Pathfinder playlist, the entire playlist of Gauss's law. There are 4 to 5 lectures just on Gauss's law in detail, so that you will get in-depth knowledge and variety of problems right from mains to advanced. Okay, now flux. What is flux? Flux is nothing but flow of anything. Okay, flux is nothing but flow. So anytime you hear this word flux, remember it just means flow. So if I say magnetic flux, it means flow of magnetic field lines. If I say electric flux, it's the flow of electric field lines. Now, whenever electric field passes through any area, actual or imaginary, then the flux is basically, how many lines are piercing through it. It's proportional to that. Okay, if more lines are piercing, you can see these lines piercing, guys, over here. So if more lines pierce through the area, then the flux is more. If less lines pierce through an area, then the flux is less. If nothing pierces, if it passes, let's say, parallelly like this, it does not pierce through an area, then the flux is 0. All right, great. All right, cool. Now, what is the formula for flux? The formula for flux is electric field dot area vector. Okay, so now I'll tell you why it is so. Imagine this. Okay, you have some area. Okay, and let's say these are the field lines passing through it. Now this is electric field. Let's say I increase the field. If I increase the field, that means more lines will pass. So hence flux is proportional to area. Understand that. It is proportional to area. Oh, sorry, my bad. Flux is proportional to field. Okay, because more the field, more is the number of lines and more is the flux. Now imagine I take a bigger area. If I take a bigger area, then what will happen? All those field lines which otherwise would not have pierced, which are passing from outside, will now pierce through that area. Hence, don't you see, those lines which were outside are also now piercing through the area. So hence flux is also proportional to area. So hence flux, the field lines which are passing or piercing through an area, are proportional to the field as well as the area itself. Now there is one more term which you might see, and that is cos theta. Why is that so? See, the logic behind that is over here. Imagine this red color rectangle is an area, okay, and the electric field, like you can see over here, the electric field is passing, okay, it's going at an angle, it's making an angle. Now this perpendicular to the area of any sheet is called as an area vector. This is area vector. Any sheet you take, doesn't matter. Say for example, okay, I take my phone. This is also a surface. Okay, this is also a surface. So if I drop a perpendicular to it, this pen right now represents the area vector of the phone. Okay, so any perpendicular drawn to the surface is the area vector. Keep this in mind. Now you can see that electric field has two components. One is the sine component and one is the cos theta component. Out of these two components, which component is piercing through this area? Visualize this. Which? Yes, Surya, I'll be doing EMI one shot also. Thank you, Nitin, for all the love from Hyderabad. Thank you, Jaddu. Alright, hi VSK, welcome aboard. Which component is actually piercing through that area? Obviously the cos component, not the sine component. The sine component is just going parallel, the cos component pierces through it. So hence, that's why you have the cos theta component. And that's the reason why you have field cos component into area. That's the reason why you have cos theta in the formula for the flux. Now, if you have understood it, we all know electric field is a vector and area, I have defined it to be a vector. Okay, I have made it into a vector quantity. Hence, I can use the dot product of two vectors formula over here. So if vector A into vector B into cosine of angle between them is given, I can, in shorthand, in formula, I can write it as electric field dot S, dot product. So that's why it's the dot product. I hope it makes sense. Okay, I hope this is clear, and it's not cross product, it is dot product because the cos theta component is responsible for the flux, not the sine theta component. All right. Now, so this is standard. Theta is the angle between the area vector and field. S is the area vector and E is the field over there. All right. Now, if I ask you what's the unit of flux, that's very easy. Field has a unit of Newton per coulomb. S has a unit of nothing but meter square. So it will be Newton meter square per coulomb. That's the unit of flux. Very, very easy. You can get it straightforward. Okay. Now, imagine a situation where you don't have a flat area but a curved area. The moment you have a curved area and somebody asks you to calculate the flux, or maybe the area is flat but the field everywhere is different. The moment you have curved areas or non-uniform field, immediately integration should hit your mind. Exactly, Amni already said that. Excelente, proud of you. So the reason for that is, any curved area can be divided into small parts, okay, like this. Small rectangles or squares or whatever, small elements. And in each element, one can think, okay, in each element, this is an element. This element has an area, for example, dA or ds. Some books use the symbol S for area, some books use the symbol A. Do not get confused. Elemental area. Okay, this is that elemental area, okay, dA. From this area, maybe the field is E, so the flux through the element, the flux through that element will be electric field over there dot the area vector. Electric field at that point into the area vector is the flux through that element. That means it is d phi. It is d phi. It's a small flux passing through that area. So the total flux through this entire curved surface will be integral, that is summation. Adding up all those small chotu fluxes, if you add all of them, you get the total flux through that curved area. Is that clear? Everybody getting it? So why do you use integration? To add, to sum up, to accumulate, to aggregate. Integrate means accumulation, okay, adding up. So flux through that small area is E cos theta dA. Integral gives you the total flux. That's what it is. Very good. Very good. Now, sometimes you might see this symbol as well. Cyclic integral d phi, or maybe cyclic integral, okay, cyclic integral E dot dA. The moment you see this, okay, the moment you see this cyclic integral, the symbol is called as cyclic integral, it means this area is not open, it is a closed surface. Correct. It is also called as closed surface integral or cyclic integral. So that means it's not an open shape, it's a closed shape. There are no openings in it. There are no openings in it. Understand? Like, for example, my t-shirt. All right. My t-shirt has openings. That's why my hands can come out. My neck can come out. My trunk can come out. This hand can come out. Imagine somebody stitched this part, somebody stitched this part, okay, it becomes like a closed surface. So that's the meaning of a closed surface. There is no opening in it, okay? Or you take a plastic bag, it's an open surface. Somebody stitches it or you zip it, that becomes a closed surface. So that's the meaning of closed surface. All right, great. I hope this is clear. So Kritika, if you don't know integration and derivative, do one thing. Watch my detailed lectures in Nurture 11th standard class. It's already there in the playlist. Can you do that? You might take 2 lectures or 3 lectures for that. I have taken in fact 4 lectures. One is via graph, derivatives, then via algebra, derivatives, then graphical interpretation of integration, and then actual problem solving of integration. So I think around 3 to 4 classes are there for sure. You can check it out. Okay, chalo, let's get moving to questions coming up on your screen right now. Thank you, Archana. Yes. So for maths also it is there, Avni. So for maths also there are separate lectures. Shimon sir would have made a playlist in the maths section. Just check it out. Hi, good evening, Kunj. Welcome aboard. All right. So let's get moving. And in a region of space, the videos that I have made are of little bit, not as per maths, they are as per physics. So they might not have very complex problems which are used in maths. So they are done for the physics perspective only, okay? So for 11th standard perspective, I have made the, that level of understanding, I have made these sessions. You can check it out. But if you want maths level, then you should go to the maths playlist. Okay, in a region of space, the field is given by 8J4, oops, I think this was 8I, guys. Okay, I think this should be I cap. Okay, this is I cap plus 4J cap plus 3K cap. The flux through the surface of area 100 units, which is in the XY plane. Let's see how many of you can get this. Come on, my warriors. Anna says answer is B. Interesting. Definitely, Trapti, it will help you. I know it is high, but it will help you. Don't get scared of solving Krotov or Irodov. It's a very good book. You should solve it. Yeah. Okay, let's try to solve this question now. Over here, this 100 units is in the XY plane. Okay, so this area, okay, of 100 units, okay, this is in X and let's say this is in Y plane, and the Z axis is over here. Okay, now electric field has 3 components. One component is 8 I cap, another component is 4 J cap, and the last component is obviously which one? That is 3 K cap. Now out of these 3 components, which component actually pierces through the area? Think about it. Which component? Is it the 8I X component, or 4J cap Y component, or 3K cap Z component? Think about it. Visualize these 3 components and visualize this surface in the XY plane. Which component is responsible for creating the flux? Obviously, yes, it's the Z component, correcto. Hence, you should only take this component actually creates the flux. It pierces through this area. That's why that flux is only that component, which is 3, into area, which is 100. Hence, the answer is 300 whatever units are there. That's it. That's the answer. Option B is correct. I hope that is clear. These 2 components are not responsible for that. Very good, very good. Excellent, my warriors. Lovely. You are amazing. Crazy. Option B is correct. Next question coming up on your screen. It's going to get tricky slowly. Vishnu, yes, you're a little bit late. You can even go back in a live session and catch up at 2x speed and reach over here. You have not missed much, but you can definitely catch up. Okay. There is a region having uniform field. A hemispherical bowl of radius r is placed. The flux through the bowl is... Come on, let's see how many of you can do this question. Which of the following options do you think will be correct? This is, let's say, the bowl. Okay, this is the bowl. Okay, so I'm just shading it. Meanwhile, before I complete my drawing, I hope you have put up the answers in the chat box. Let's see how many of you can get this correct. Okay, so this is our bowl and our field is going to go like this, pierce this way. It's going to go like this. It's going to pierce like this. Okay, it's going to pierce like this. This is uniform field. Okay, what do you think is the answer to this question? Janice says C. Interestingo. Okay. Come on. Avani is also saying C. Archana also saying C. Interesting. Okay, Sai also saying C. Kritika saying A. Interesting. Guys, dimensionally A will be wrong. Think about it. Kritika, this has A, dimensionally it has to be field into area. 2 pi r is circumference. So that's why dimensionally only this option will be wrong. Okay. Karishma, yes, it's not just about completion of syllabus, it's about solving problems and mock tests. Just completing syllabus won't help. Okay, so a lot of people think just if I complete the syllabus I'm done. No, it's not. You have to complete the syllabus obviously, but there is more to it. In fact, watch my session, how to score really good percentile in JEE 2022. I've conducted it few days back only. If you just scroll up through our videos, you will get it. Just few weeks back I have conducted it. Now the logic over here is, do you agree that whatever flux passes through the flat surface, or rather whatever lines pass through the flat surface, I'll just put it over here, number of lines through circular flat surface, can I say is equal to, can I say it is equal to the number of lines through the hemispherical surface? Do you agree with this? Okay, Karishma, then that is good. If you are solving PYQs and different books, yes, you are on the right track, bacha. Okay. Whatever line passes through this blue surface has to pass or cut through the curved surface. Do you guys agree? So then can I not say that the flux through the hemisphere, because at the end of the day, what is flux? Flux is nothing but number, it's a proportional to the number of lines. If the lines are same, doesn't matter how the area is, the flux has to be the same. So this flux should be equal to the flux through the flat circular surface. Isn't that true? And now think, what is the flux? What is the flux through this flat surface? It's area of that circle multiplied by the field. Now what is the area of the circle? Pi r square. What is the field? That's E. So hence it should be pi r square E. That is the answer. Everybody getting it? So the concept over here is basically convert the curved area into a flat area, equivalent area, which will have same number of lines cutting through it. In fact, these kind of questions have also come up in different manner. I'll tell you how. Imagine there was a cone given and there was a diagram like this. The field is cutting through the cone. Now the question asked was, how much is the flux? Okay, how much is the flux through this curved area? Don't you see the flux through the curved area is the same as the flux through the circular area? So the answer for the cone problem should also be pi r square E. Everybody getting it? Understood? So that's the logic behind it, because flux is proportional to lines. So just make an equivalent diagram which is more convenient, which will have the same number of lines cutting through it. That will greatly simplify the problem. Excellent, Sai Shruti. Very good, Sai Prasanna. Very good, Archana. Glad you understood. Glad, Kritika. Very good, Sai Prasanna. Excellent. Yes. So, Trapti, maybe you can post up that question later on. I will reply to it because I don't want to break the flow of my teaching right now. Okay. So the correct answer is D. Okay. Now let's go to Gauss's law. Now, how to revise efficiently, I have also mentioned a detailed timetable, Avni. Okay, just check out JEE 22, how to crack it by Shreyas Sir, just few weeks back. Just check out the video, timetable, how to revise, and everything has been mentioned in that video. It will just follow that video. Trust me, you will get not just 99, you will get 99.9 percentile in JEE next year. Gauss's law. Now, whenever you have some charges inside, outside, etc. And you visualize an imaginary surface. It might not be actual surface, it's just an imaginary surface. And this surface has to be closed. So if this is a closed surface, such a surface is called as a Gaussian surface. What is it called? It is called as a Gaussian surface. Now, each of these charges might create some field. Obviously, let's say this charge is positive. So maybe it is creating some field like this. Maybe there is field like this. Maybe because this is negative. I don't know. These are just examples, guys. Okay. So these are the field lines which are coming out of this particular system. Okay. This is how it is. And maybe they go like that because maybe this is positive. Okay. I don't know. Okay. So something like this. These are the field lines coming out of this charged random system. Now, don't you see there is some flux cutting through? There is some flux cutting through the surface. If you measure the total flux, then Gauss said this total flux is only dependent on the inside charges, and that is equal to enclosed charge or inside charges divided by epsilon naught. So that's what Gauss law is. Simply put, if you take the electric field at any point, okay, and you also see what's the area vector. Let's say this is the area vector and this is electric field vector. So if you integrate cyclically everywhere, so if you take E dot dA, what is E dot dA? Flux. So closed surface integral, the total flux will be enclosed charge or inside charge divided by epsilon naught. That's what Gauss's law is. As simple as that. Gauss's law, does it have high weightage? So guys, it's not about whether it has high weightage or not. See, a lot of teachers and coaching institute, even on YouTube and even offline, they give you the weightage of chapters, which is definitely not correct. See, just before the exam, just 1 or 2 months, we give you because, you know, you have to do something. So that time weightage makes sense. But for a long-term student, that is very, very poisonous. That is very, very harmful. Please never ever look at the weightage, whether this is important or not important. It's not about that. You have to learn everything. Just remember this, okay? So please do not watch weightage videos on YouTube for specifically 2022 or 2023 students. Okay, yeah? Okay, chalo. Yes, Archana, I will be making session on magnetism also. Yes, Riya, usually I conduct my classes at 7:30, but today I made it at 7 because I thought this session might be longer and I didn't want to overlap it with Shimon Sir's class. So that's the reason why I conducted it early. Alright, so the net flux is only because of inside charges. The field is because of inside as well as outside charges both. Because remember, at any point, if you take, okay, at any point if you take, this point charge will give a field, this point charge might give field, this point charge might give some field. So E1, E2, E3 together will give you the net field at this point. So this E is the resultant of these three fields. So at every point the field is because of all of them, but the flux is only because of the inside charges. That's what Gauss's law is all about. Let's see whether you're attentive or not. Hi Sidhu, good evening bacha. Yes. Yes, let's get going. Okay. Do you think we have long time period? Yes, I feel that you still have time, bacha. Don't get scared. I know the time is less, but I don't want to demotivate you also. If you only think that, oh, my time is less, I have only few months, then you are going to hurry up through the chapters. And then again after a few months, you will be like, sir, I don't know the concepts in detail. What do I do now? What is the strategy? So I don't want you to reach that stage. So that's why I'm saying read whatever you are reading properly and read it thoroughly. Even if you don't solve very difficult problems, advanced questions, I'm still okay with it. I'm not saying you should solve advanced questions right now if time is less. Yes, do mains level questions, average questions, that's fine. And once the syllabus is over, then do advanced questions, that's also okay. Okay, so don't get demotivated even if your syllabus is not yet over. Some of you are saying true, some of you are saying false. The answer is false. I think I just told you this, that the field at any point is because of all the charges. I just told you, I just showed one diagram. So the field is only due to the charges which are enclosed this is wrong. It is not only because which are enclosed, in fact, and which are outside as well. This is very, very important. So when you write this, cyclic integral E dot dA is equal to enclosed charge by epsilon naught. Remember, this value, this whole value, this depends on inside charges, but only this value is because of in and out both. So when you have a Gaussian surface, if there are charges inside and outside, at any point when you say this is the field, this field is the resultant of the fields due to all the charges. This charge might give field here, 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 this charge might give field here. So this is the resultant of all the fields. Keep this in mind. I hope this is clear. Okay, very good. So the charge outside does not give flux, net flux. Net flux is 0 because of the outside charges, but inside charges and outside charges together contribute to the field. So, but the integral value is not dependent on outside charges. So that's what it is. Very interesting question. Let's see the next question coming up on your screen. The electric flux over a sphere of radius 1 meter is 5. Now, if the radius of the sphere were doubled without changing the charge inside, the net flux would become how many times? I have doubled the radius. I have doubled the radius. Janish, that's because of the number of questions and the pattern of questions in BitSat, because they have, logical reasoning, English and all of that. So that's why it's really tough over there. Okay, same D. Okay, interesting. Some of you said B, Avni saying B, interesting. Guys, the correct answer is actually D, and the reason for the answer being D, very good, I'm proud of you, my warriors. You are true captain's warriors. Yeah, Cap to Shreyas is proud of you. Okay, so what has happened? If you have a sphere, okay, and there is a charge over here, okay, now what will happen is that there will be some flux coming out of it. That means some field lines coming out of it. Now, if you double the radius, a lot of you might think, oh sir, area is increased, so the flux will increase. Wrong. Although flux is field multiplied by area, you might think area is increased, so flux should increase. Remember, when you reach here, the field itself will reduce. The field will reduce. It will compensate, because when you go far away, the value of the electric field reduces. So they are inversely proportional, and that's why the flux remains same. Not just that, even if you go by Gauss's law, all right, this should be only enclosed charge by epsilon naught. This is same no matter how big sphere you take. So the answer will be independent of that. Not just that, in fact, if one did not even take a spherical surface, somebody took some weird looking surface like this, some amoeboic shape, even this surface will still have the same flux phi, because the enclosed charge is the same. So remember, as long as enclosed charge is same, the flux will not change. Yep, I hope this is clear. Okay, chalo, let's get moving to the next question coming up on your screen. Now, beautiful question. This is multiple correct type. So this is advanced type of question where you have more than one options correct. Read each and every statement. There is a point charge Q which is placed just outside the imaginary hemispherical surface. It's a closed hemisphere, okay, imaginary, of radius r. Which of the following statements is r correct? Think about it. Come on, my warriors. A point charge is placed just outside an imaginary hemispherical surface of radius r as shown. Which of the following statements is r correct? Think. Surya saying C and D. Interesting. Come on, my warriors. You can do this. It's not that difficult. Trust me on this. Okay. So let's try and do this question. The electric flux through the curved surface. Let's try to draw those field lines first. That might give me some idea of how things are going to happen. So maybe I can show one field line here, one field line here, one field line here, maybe one field line here, maybe like this and like this. There will be so many other field lines coming out of it, okay, in all the directions. Okay, I'm just showing some of them. So these are the field lines which are going to come out of it. Cool. Now the flux passing through the curved surface. Remember, on the curved surface, think about it, on that curved surface, the field lines are coming inside of it. The field lines are coming inside of it. Do you see that? The field lines are coming inside. Most of them are coming inside. Whenever field comes in, that is negative. And whenever it goes out, it is positive. You would know this because if I take a positive charge, if I take a surface, Gaussian surface, field lines will come out of it. So the flux is positive. If I have a negative charge, then the field lines will come in. The net flux is negative. So whenever you have a closed surface and field lines are coming inside of it, then it is negative. Keep this in mind. Kavita, welcome. Join in. You missed quite a few things. So option A is correct. Everybody getting this point? Everybody getting this point? Why A option is correct? Okay. Total flux through the curved surface and flat surface is this. This is obviously wrong. Reason is, through the curved and the flat surface. That means the total closed surface, understand, will be 0. Reason, this charge is outside. Be careful. It is not inside of this hemisphere. It's outside of that. Hence, option B is wrong. So I will not mark it. Everybody clear? Now, the component of the field normal to the flat surface is constant over the surface. This is also wrong. I'll tell you why. This is our flat surface. Okay, this is our flat surface. The component of the electric field normal to the flat surface is constant. It's saying this field's vertical component everywhere, this vertical component or this normal component is same everywhere. Guys, first of all, the value of the field itself is different everywhere. E1, E2, E3, E4. Their component, vertical component, this one, okay, this vertical component is also going to be different because the angles are different. This is E2y. E2y will be E2, some cos theta, and this theta will also change when you go from one point to the other. So definitely that vertical component is not constant everywhere. I hope this is clear. Hence, this component of the electric field normal, so that is basically E2y or E1y or E3y, all these are not same. None of them are equal. Okay, so they are generally not same. Most of them will be different. Now, the circumference of the flat surface is equipotential. Now, if you remember carefully, what was equipotential surface? All the points where the potential is same. And what is the speciality of equipotential surface? The electric field lines are perpendicular. Electric field lines are perpendicular to the equipotential surface. Now, do you see the electric field lines being perpendicular on the flat surface? Obviously not. Obviously not. Yes. So hence, understand that the potentials on all the points on the flat surface is not is an equipotential surface. That is definitely wrong. Yes. So this is definitely wrong. I hope this is clear. Yep. So what if the charge at the center of the circle having same angle with the area vector? Then if supposedly, Vishnu, angles were same somehow, okay, not point charge will never give the same angle. Let me tell you that, because the field lines will come out at different angles from a point charge. But if you have a charged sheet, then the field could have been uniform and then the surface could have been equipotential and all of that. Yep. So only one option is correct. Yes. I hope this is clear. Everybody clear about this? Yep. Cool. So let's get moving. So only option A is correct. Okay. Let's get moving. Next question. A charge Q is placed at the corner of a cube. The flux passing through one of those faces which does not touch the charge is. Interesting question. coming up on your screen. Interesting question. Let's see how to solve this. First of all, okay, let's draw a cube so that you guys visualize what is exactly happening. Okay, so this is our cube. Okay, and this charge is placed over here. Now a charge q is placed at the corner of a cube. The flux passing through any one of those faces not touching that charge. So left face, front face and bottom face are almost touching the charge. Top, right and back are not touching it. Now everybody can visualize the field lines will come out of it. Now whether I take this surface or whether I take, this surface, okay, the flux through either of them will be same. Do you guys agree? Why will the flux through these two faces will be same? So if I'm at the corner, okay, visualize the field lines coming out of it. How many of our field lines will pass through this part, will also pass through this part. It's a cube, remember, it's not a rectangle or cuboid. Okay, so you can always rotate this cube and you can always see the number of lines passing through any one of this or even the behind surface is symmetric. Everybody clear about this? Okay, now let's try and do this. Swarlina already saying option A is correct. Neat. Hold on, bacha. It will come up in, what do you say, nurture series. So it will take some time, okay? Because right now we are in 1D and basic math. Probably next week or next to next week I'll upload it. Not now. Okay, now, but if you want the detailed classes of Newton's laws, which you should not be completely dependent on one shot. One shot is dangerous. If you just watch one shot plus regular sessions are the correct way of watching the sessions on YouTube. If you are only watching one shots, definitely you are not going to succeed. Okay, remember that. Okay, now what you need to do, let's make an imaginary cube which will help me analyze how much flux is passing through it, because right now it's difficult to visualize how much flux is passing. I know one thing for sure. If I have a cube and if I have a charge at the center, each surface will have the same flux. If I have a charge exactly at the body center, all of those fluxes will be same. Do you guys agree? Be it sides, be it top, everything will be same. Everybody understanding this? Clear about this? This is a JEE channel. Let me remind you of that. Yeah, this is a JEE channel. Okay, so we have separate NEET channels as well. Now the problem is the charge is not at the center, it's at the corner. So somehow let's make it at the center by imagining a bigger cube. How do I do that? Well, just draw a bigger cube. Very easy. So I'll just draw one more cube over here like this. Just try to visualize this, guys. Okay, this is one more cube beside it. Okay, beside it, and then one more cube over here. There is one more cube over here, and like this. Now there are 4 cubes. Right now, this charge is at the face, roughly at the face, not closer to you, okay, of these 4 cubes. Still, it is not at the center. So draw 4 more cubes like this. Draw 4 more cubes like this. Visualize how it will look like. It will look probably something like this. Okay, and maybe I can draw something like this over here, and 4 more cubes over here like this. And yep, I guess now it's fine. Okay, something like this. I hope you are able to visualize this charge is right now at the center of it. Is it clear? Is it clear? Yes, Kavita, I do remember you. Gaussian surface. Now, it should be obvious that if I take a big surface over here, big surface, the flux through this big surface is 1/6 the flux through the big cube, because 1, 2, 3, 4, 5, 6 big faces are there. Everybody clear about this? There are 6 big faces of that big cube. How much is the flux passing through the entire cube? How much is the total flux passing through the entire big cube? It's a closed surface, so enclosed charge by epsilon naught, enclosed charge is q and epsilon naught as it is. So the flux through that big surface over here, okay, this surface is nothing but 1 by 6 q by epsilon naught. Now think about it. The flux through this surface, 1, 2, 3, 4. There are 4 parts equal. So the flux through that surface which I want, okay, will be 1/4 of the flux through this big surface. Hence, what should be the answer? 6 into 4, 1 by 24 q by epsilon naught. That is the final answer. Everybody clear about this? Got it? So I have created an imaginary cube so that the diagram becomes symmetric. The charge comes at the center, everything is equal, and then I slowly went back to my original problem statement, and by symmetry I have figured out the fluxes will be equally distributed, and I found out that it is 1 by 24th times. Yeah, that's the answer. Okay, so that should be the answer, I guess option A. Yep, that's correct. Thank you guys. Hello Silwai Panamiyam, welcome aboard. Very good Kavita, very good Avni, Malvika, Vishnu, Swarlina, Hindutva, welcome. Yes. Oh, your name is Remo. Okay, I shall remember that. Great. Is it advanced level? Well, it's between mains and advanced, somewhere in between. Okay. It can come in mains as a difficult question or in advanced as a very lallu question also. For advanced it is lallu, okay, but for mains it's good. Okay. Now before we go ahead, let me remind you, if you want this book, what is this book? This is the hard copy which we give you. And this is there for all the chapters. So a lot of you struggle, sir, which book should I study from? I always tell NCERT, H.C. Verma and Tattva and previous year questions. In fact, previous year questions are there in this. The recent previous year questions are all there. But if you want very old questions, there is Arihant ka book, which you can get it. But this book has easy questions, medium questions, previous year questions, hard questions. Not just that, formulas, concepts, important pointers, do not do's and strategies. Everything is there for all the chapters. You get this for free if you are a part of Vedantu Pro subscription. And did I not tell you that Vedantu Pro subscription 50% offer is going on, limited time sale. Usually the offer is how much? 20%. So do not ask me later on after a few days, sir, I wanted that 50% off. Guys, I cannot do anything after few days. So that sale is limited. So check it out and you will get this book if you join the full long-term batch, all right, or the long-term pro subscription, if you take it for 1 year or 2 years. If you are 12th standard, you will take it for 1 year. If you are 11th standard, you are going to take it for 2 years. All right, let's get going. Thank you, Abindan. Yep. Now, let's move on to the next part. I have showcased how to exactly get the field or potential using Gauss's law in my regular Pathfinder series. So why do you study Gauss's law? Apart from finding flux or enclosed charge, the other application is to find out the field due to different geometries which otherwise would be difficult via integration. So Gauss's law enables us to find out the field due to some nice geometries like spheres, line charges or sheets using simple Gaussian surfaces. How to do that? I have explained it in detail in the playlist of Pathfinder of Gauss's law. Just check it out. Okay. Now, the final results are also very important. This is the field and potential due to hollow sphere of mass m, radius r and total charge q. Hollow means these charges are on the surface. Charges on basically the surface. Inside is empty. Now, when you are outside, r is more than r. That means you are outside. Okay, this first part is outside. The second part is when you are inside. Now, when you are outside, the problem is very simple. This entire sphere behaves like a point charge. So think of this entire sphere which is charged, okay, like a point charge. That's it. The point charge at the center, and whatever is your distance, That's it. The field will be kq by r square. Simple formula for a point charge. So the entire sphere behaves like a point charge. That's what you need to keep in mind. Second thing, yes, Ram Kailash, you can get the Tattva material for pro subscription class 12th, and you will get class 12th material only. Yep, you'll get class 12th material only. Okay, so Surya, if you're not able to do problems, I have been telling this again and again repeatedly. You have to watch the video lectures of teacher solving problem. You have to be very regular in classes. Pay attention why the teacher is doing why, what things, what steps, and what order. Not just that, after every class, revise through the notes, solve the same problems, and then go through the solved examples, and then go through easy problems, and then go to the average problems. Never look at the solutions, and always make sure you put in your sincere best effort, and wherever you get stuck, only then look at the solution, but only partially. That's what my advice is regular. I have been giving this advice regularly anytime any student asks this. Okay, Ram Kailash, my micro courses are available for both JEE as well as NEET. So my courses, whichever you find on pro subscription, are for both the batches. All right. So how to make notes? VSK Chaitanya have already made a detailed lecture. Just search for Shreyas Sir notes. You will get it. Okay, check it out on YouTube. But when you're inside, the field due to all the charges, cancels out. That's why it is a big 0. Keep this in mind. The field inside is 0. Okay. Now potential. When you're outside, this entire shell behaves like a point charge. So again, this entire shell is behaving like a point charge. So potential is kq by small r. What is small r? The distance. What is capital R? Capital R is the radius. Keep this in mind. So you are outside, like I have mentioned. But when you are inside, this is very important. This is capital R. Notice there is a small change. Why? Because the potential inside will be constant. Why is it constant? Because field is 0. Why would 0 field mean constant potential? Do not forget, in my previous revision class or even my detailed classes, I have been mentioning this again and again. E is minus dV by dr. This is the formula. So if field is 0, then derivative is also 0. That means there is only one thing. Voltage is constant or potential is constant. Derivative of a constant is 0. Keep this in mind. Okay, clear? Very good. Very good. This is very, very important slide. So field outside, inside. When you're outside, it behaves like a point charge. Remember, when you're inside, the field cancels. Field is 0, so potential is constant, and it is kq by the radius of the shell. Next, if it is uniformly charged, remember, this is, uniformly charged. That means charges are even there inside. The charges are even there inside the sphere. Okay, and if you are outside, the formulas are same. That means the entire sphere, okay, if you are over here at this point, the entire sphere behaves like one point charge, and this distance is all that matters. Radius does not matter, radius of the sphere, only the distance from the center matters. That's it. So when you are outside, it's simple, but when you are inside, be careful. So if you are inside, okay, if you are inside, R is less than R, then the formula is slightly different. It is kqr divided by r cube. kqr divided by r cube. You can also see if r is 0, then the field will be 0, which makes total sense. That means if you are exactly at the center, the field being a vector will cancel from all the sides. That's how you can remember this. So in the numerator, you have that variable r. So if the variable becomes 0, the field vector will cancel from everywhere. Okay, yes, all this comes from Gauss's law. Okay, so it's me. You don't need 0 to hero series for current electricity. We have already done it in rank booster. So it's me. The 0 to hero was for 2021 batch. You are not 2021 batch, bacha. You are 2022 batch. So focus on the Pathfinder. Do not watch 0 to hero series. It's not for you. It was for the 2021 batch. So don't watch that. Concentrate on this classes, Pathfinder series. Next thing, for potential, KQ into 3r square minus r square divided by 2r cube. This is the most complicated formula for potential. You should remember it. Keep this in mind. Okay, so this is the formula for the potential of a uniformly charged sphere when you're inside of it. The formula in gravity was also similar. If you remember, instead of k you had g, instead of q you had m, and there was a negative sign outside, but it's okay. I mean, it's k cube 3r square minus r square divided by 2r cube. Very, very important. Next, let's get moving to the next one. Field due to a ring and the potential. So if you have a ring which is charged, like this, then each point on the ring will give fields in different directions. The sum of all these fields due to all these charges will come out to be like this. This is the net field, and this is given by kqx divided by r square plus x square whole raised to 3 by 2. Very important formula. Notice this x on the top. Now the way to remember it is, if x is 0, so if you are at the center, think about it, if you are at the center, the fields will cancel, hence the value should be 0. Yes, this value will turn out to be 0 if x is 0. That's why x is in the numerator. That's how it is. Yep. Hello PL, welcome aboard. Hi Ankit, join in. Yep. So that's how it works. Similarly, potential is just kq divided by r square plus x square whole raised to 1 by 2. See guys, this distance by Pythagoras is r square plus x square. All the charges on the circumference or on this ring are equidistant. That's the distance kq. The distance is root of r square plus x square. Hence, all the charges being equidistant, the potential is just kq by r. That r is that distance, and that distance is root r square plus x square's root. Yes, so that's why the potential is just kq by r square plus x square raised to half. Remember, potential is scalar, so there is no need of vector addition. Don't take components for potential. Only for field you will take components, but for potential it's just the addition of the potentials due to every one of them. Yep, I hope this is clear. PL, if you are already regular to our sessions and our channel, you already know all the previous sessions are there in the playlist, bacha. Just go through the playlist, it's all there. Okay. Similarly, for a charge sheet, hi Vaishnavi, welcome aboard. Yep. What is x? Oops, what is x? X is the distance from the center to the point where you are measuring the field along the axis. So if you have a ring, if this is the ring, this is the axis of the ring. So this is nothing but x, the length from the center to the point where you are measuring the field. This is a special case when you have a charge sheet. Keep this in mind. Whenever you have a charge sheet, the field due to that is uniform and it works both ways. Okay, so if you have a charge sheet, the field lines will go on both the sides. This is uniform electric field. Very, very important. Now you will see sigma by 2 epsilon naught over here. What is this sigma? This is, charge density. This is charge density, and the unit of that is coulomb per meter square. What it means is, if somebody takes 1 meter square of area, how much charge is there? So how much charge is there per unit area of that sheet? So that's nothing but sigma. It is usually given, or you will be given the area and the total charge. If let's say the total charge is 5 coulomb and the total area is 2 meter square, then it will be sigma will be 2.5 coulomb per meter square. As simple as that. It's the charge density. Keep this in mind. And very important, this field is uniform. I am repeating this again. It's uniform. So if you have a sheet which is positively charged, it will go outwards. Okay, and if it is negatively charged, then it will come inwards. Okay, because it's negative charge, the field will be a pulling, attractive towards inwards kind of thing. Okay, so that's how it works. Lastly, if you have a wire which is charged, then each point on that wire will give rise to some field. Let's say this point charge will give a field here. 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 This charge will give a field here. This charge will give a field here. You can see the fields due to all the charges are there in all the directions with different magnitudes because the distances are different, angles are also different. So the resultant of all these fields will come out to be, okay, the resultant might come out to be like this. Maybe there is some x and there is some y component, and that fields, both components are given by this formula. K lambda by r, for x component it is sine alpha plus sine beta, for y component it is cos alpha minus cos beta. Now what is this alpha and beta? I'll just give you an example. If you have a wire like this and you want to find what is the field here, this is r. First join the end points. The angles made over here are alpha and beta. So the point where you want to find the field, just join a line to the end points of the wire. That will give you alpha and beta. So for example, let's say you have an infinite wire. If you have an infinite wire, okay, it extends from minus infinity to plus infinity and you are over here. Think what should be the value of alpha and beta. What should be the value of alpha and beta? Quickly let me know in the chat box. I will tell you what is that lambda meaning. I'll let you know. Hold on. I'll just tell you what is that lambda's meaning. Yes, both alpha and beta both will be 90 degrees. Correct? Both alpha and beta will be 90 degrees. So if you substitute it, cos 90 and cos 90 is 0. So EY will be 0, obviously. EX will be K lambda by R. Sine 90 is 1. Okay, sine 90 is also 1. So I'll get it as 2K lambda by R. That's what I will get it. So the field is only in the x direction. There is no y component. The y's are getting cancelled. Now, what is this lambda? This lambda is how much charge is there per unit length. If I take 1 meter of that wire, how much charge is there? So that is basically lambda. So lambda is linear because it's line charge. So linear charge density. That's the only difference. Sigma was coulomb per meter square. Lambda is coulomb per meter. Per meter, how much charge is there? That's what lambda is all about. That's it. Understood? So you should remember all these formulas and yeah, which one is sine, which one is cos, all of that. Okay. So quickly going through all the formulas. The first formula was for a shell. Shell behaves like a point charge. Inside the field is 0, potential is constant. For a uniformly charged sphere, when you are outside, it still behaves like a point charge. The only difficulty is when you are inside. So these are the two little difficult formulas. Similarly, for a ring on the axis, the field is kqx divided by r square plus x square raised to 3 by 2, and potential, because it's a scalar and all the points are equidistant, it's kq root divided by root r square plus x square. Due to a sheet, the field is uniform. This is the only geometry which gives you uniform field. Keep this in mind. And the field is sigma by 2 epsilon naught. Sigma is having the units of coulomb per meter square. Per unit area, how much is the charge? And lastly, due to a wire or due to a charged conducting rod, the field at any point will be given by k lambda, and you can have sine alpha plus sine beta or cos alpha minus cos beta divided by r. R is the distance from the wire. Alpha and beta are the angles which are subtended by the ends at this point. Lambda has the units of coulomb per meter. All right, cool. Let's get going. Okay, ready for some questions, guys? Ashma, you're very late. Join in at least for the last few questions. Okay, so maybe you can watch the lecture later on, whichever part you have missed. Come on, my warriors. Two concentric shells have charges plus q and minus q. Choose the correct option. Come on. Thank you, Sneha Bacha. Jupudi Ratnam, why don't you post the answers in the comment section after the session is over? Definitely I'll help you out. Okay. Oh, by the way, I've Remember, multiple correct. This is multiple options correct. So keep this in mind. So multiple options could be correct. Let's see how many of you can get it. Sanjeevan, I have completed gravitation last year. I've also done it in Zero to Hero series and all of that. But this year, obviously, I'll be doing it towards the end of 11th standard, because gravitation is one of the last few chapters. Okay, cool. Yes, come on. Venkat, I have already mentioned what lambda is. Lambda is linear charge density. Yes, it is. Okay. So basically, if you are losing interest, then the only way is stay with motivated people, make friends who are constantly studying for JEE, and make sure that you constantly attend the classes, live classes, and participate and keep solving problems. Even if it is easy, difficult, doesn't matter, but keep solving problems and stay with a motivated group who continuously discusses, and always make sure that you stick up a poster or stick up your aim on the wall as to what you want to do and what you want to get into, which branch or which college you want. So that will make sure that you do not sleep or do not lose interest. So yeah, please make sure your ambition is always in front of your eyes. Option A and B. Well, the correct answers are actually A, B and D. Interesting. Go. Let's see why is it A, B and D. See guys, first of all, the shells have charges Q and minus Q. Choose the correct option. At A, the field is 0. Yes, this point A is inside both the shells. It's inside both the shells. So the field inside is 0. We have just seen that just some time back. Whenever you have a shell which is charged, inside it is 0, outside it is non-zero. Keep this in mind. So yes, the field should be 0 due to all the shells. So the A option is correct. At B, the field and the potential both are not 0. At B, what will happen? B is outside this plus charge, but it is inside the negative charge. So what is happening for B, guys? B is inside, look at that, it is inside the negatively charged shell, inside the negative, but outside the positive shell. Now the shell which is for which B point is inside, the B point is inside, that will not give any field. So this negative charge is not going to give field at this point, because point B is inside that shell. But this shell which is positively charged, for that you are outside. So this positive charge will behave like a point charge at the center, and the field will be there. In fact, the field at point B will be KQ divided by R, whatever is that distance, R. So that's going to be there. And potential, well, potential is always there, whether you are inside or outside. We have been seeing that. Yep. So potential is going to be there. So for this shell, you are outside. So the potential at point B will be KQ divided by R. Why? Because you are outside of it. You are outside of it. But the potential due to the negative charge, do not forget, when you are inside, the potential is constant everywhere. And because it's negative charge, so I'll put minus KQ divided by the radius of the outer shell. Okay, so I don't know what the radius is. So if I have to call it as R1 and let's say R2, so this is going to be R2. Is that clear why this R2 has come? Because you are inside of that shell. So the potential is constant because of the outside charge. Okay. Kavita, Menti quizzes are actually very harmful in the long run. Just Menti quizzes is bad. Once in a while Menti quizzes are good, and that's why after every chapter I have conducted Menti quizzes. Menti quizzes are great, trust me, till 10th standard. But for JEE, it doesn't work. So I know a lot of channels might do Menti quizzes only, and that will be disastrous, because then the questions will be easy and you will get used to only easy questions. So once in a while, yes, it's supposed to be done, it's very good, but only Menti quizzes is bad. In fact, you're supposed to understand and get excited about this problem solving and all these kind of concepts out here. Not just that, if you want timed practice, we have assignments, and we have mock tests in our pro subscription. Please check it out. So you can give all these mock tests in a timed manner at home. So you will get that feeling of Menti quizzes. Plus you will also get to see your relative performance as well. Now at C, the field is 0, but potential is not 0. Now at C, the field is 0, but potential is non-zero. Well, that's wrong. See guys, at this point C, the net field will be 0. Reason is, look at that, the field at point C will be k q by r square due to the positive charge, and minus k q by r square due to the negative charge, because for both the shells you are outside, so the total will be 0 undoubtedly. In fact, even the potential will be 0. Potential at point C will be k q divided by r minus k q divided by r. Both will be 0. Here it is saying non-zero. This is wrong. Okay, so this is why this is wrong. I hope this is clear. Great. Now last point, at C the field and electric potential both are 0. Yes, I just mentioned it. Both the field and potential are 0. What an interesting question. Did you guys love it? Can we go ahead to the next question coming up on your screen? Yep. What a brilliant question. Completely conceptual, based on inside and outside of shells. Let's get moving to the next one. Okay, this one is easy. You should be able to do it within 10 to 20 seconds, but still I'll give you a timer if you guys are interested in the timer. Let's see how many of you can do this within 1 minute. A solid conducting sphere of radius r has charge plus q. What is the electric potential within the sphere at a distance r is equal to r by 3 from its center? Very interesting question. Come on my warriors, figure this out quickly. What do you think is the potential at a distance of r by 3? What do you think is the potential? Come on my warriors, figure this out. Let's see if you can guys get this. Very easy. Kavita, I just mentioned about Menti quiz, bacha. Yeah. GGFF, hello, welcome. Oops, looks like people are confused. A, B, interesting. C also. Okay, well, the time is running out. Venkat, I'm very good, bacha. I'm very good, thank you. I hope you two are doing good. Manoj saying D, GGFF saying A. Well, the time is up and the correct answer is option C. Read the question carefully. It's a conducting sphere. So the moment it is a conducting sphere, what will happen? Okay, even if it is a solid sphere, the charges will only be there on the outer periphery. The charges will only be there on the outer periphery. So this solid sphere will almost behave like a shell. And in fact, whenever you have a shell, okay, so what will happen? Everywhere the field will be 0 and the potential will be constant. Remember that? Because the charges are on the surface. So potential is constant and it will be k q divided by r. This r is nothing but the radius of the shell or the sphere. That's it. I hope this is clear. Everybody getting it? So that's how you get the answer. Okay, let's move on to the next question coming up on your screen. Now, this is also a brilliant question. Two identical thin rings of radius r are coaxially placed at distance r meters from each other. If q1 and q2 are the charges on the rings, and you have to move a charge from the center of one ring to the center of the other ring. This kind of question was asked in JEE mains, trust me. And many people made a mistake over here. Let's see if you guys can understand this. So I'm starting from the beginning. How much is the work done in moving the charge from center of one to the center of the other? Let's say this is q1 and let's say this is q2. And let's say I want to move it to this point from this point. We all know that the work done in moving a charge is charge into the potential difference. Now this potential difference will be Q into, let's say, V2 minus V1 or V1 minus V2, whatever you want to call it. I'm only interested in the magnitude of it. So let's just find out the magnitude of the work done, okay? Because it's not mentioned whether you are taking it from 1 to 2 or 2 to 1. So that's why I'm finding out the magnitude. So how do I find V1 and V2? So you have to find the potential at this point. You have to find the potential at this point. And then you have to take the difference. Let's do that. What will be the potential at point 1? The potential at point 1 will be due to this charge and due to this charge. Understood? Both rings will give potential. Only due to Q1 charge, because all the charges are equidistant. Remember, this is just R. By the way, this is also R, and yep, this is also R. Okay, so all the charges are at the same distance R. Hence, what will happen is the potential will be K Q1 divided by just R. That's one of them, plus the potential due to Q2 charge. Do not forget the Q2 charge is at a distance of, what is this distance, guys? What do you think is this distance? This is nothing but root of R square plus R square, which is nothing but R root 2. We are just seeing that formula, R square plus X square. Anil Kumar, I'm very good. Welcome aboard. So hence, I should just put over here as K Q2 by R root 2. That's V1. Similarly, what will be V2? Potential at this point will be due to this charge plus the potential due to this charge over here. The potential due to Q2 charge will be, think this way, all the charges are at the same distance R. That means it should be just K Q2 divided by R. It should be just K Q2 divided by R. Now, the potential due to the Q1 charge at the center will be how much? It will be K Q1 divided by R root 2. Why? Because again, think about it, this distance is also R root 2. All these charges are equidistant from the center. Makes sense? So, these are the 2 points. So, now just take the difference of them. That's it. So, just take the difference of them. So, I'll get V1 minus V2 will be K by R is a constant. So, I'll be left with Q1 minus Q1 by root 2 plus Q2 minus Q2 by root 2. I have taken K and R outside. So this will become K by R. Okay, I'll have Q1, okay, into 1 minus 1 by root 2. 1 minus 1 by root 2. And I can also take minus over here outside, and Q2 into again, I think 1 second. Over here, just 1 second, guys. Yes, 1 second. This was supposed to be Q1 minus Q2 by root 2, and here I have Q2 by root 2 minus Q2 over here. Yes, this is Q2 by R, so there will be 1 over here. Now let's see what more I can do. This will be K by R, and I'll have Q1 common, and this will be 1 minus 1 by root 2, and here I can take the negative sign common and Q2 outside, and this will become 1 minus 1 by root 2. Now once I get this, I can take 1 minus 1 by root 2 also common, so it will become K by R into 1 minus 1 by root 2, and here I will have Q1 minus Q2. That's it. So that's what potential difference is coming out to be. Once I get potential difference, what's the last step to find out the work? Yes, once I got, the potential difference, what's the last step to find out the work? Multiplied by Q. So the work will be this whole thing multiplied by Q. So if you multiply it by Q, you are going to get the work done. As simple as that. Okay, so how to get V2? V2 is basically nothing but, think about it, the potential due to these charges over here, all the charges over here. So that's nothing but K Q2. Q2 is the charge here divided by R. R is the distance from this center to, and plus K Q1 by R root 2. R root 2 because this distance is also R square plus R square's root, which is R root 2. So all these charges are at the same distance, and this charge is nothing but Q1. So that's why K Q1 by R root 2. As simple as that. I hope this is clear. Okay. Jagdish, you can post up your comments after the video ends. I'll definitely help you out, but let's not break the flow of the session. All right, come on. So that's how you get it, and that's the final answer. K is 1 by 4 pi epsilon naught, Q by root 2 R, yes, Q1 minus Q2, and you can take the LCM. So if you take the LCM, root 2 will come outside, and root 2 minus 1 will come on the top. Clear? Can we go ahead? Come on guys, show some love, show some Josh. Why K Q1 by R2? Vishnu, because all the charges are at the same distance, and remember that formula? I just gave you that formula. If you have this as X, this is R, the potential is K Q, if this is Q, okay, divided by R square plus X square. So if X is 0, it will be just KQ divided by R, because all the charges are at the same distance. X is 0. I hope this is clear now, Vishnu. Okay, so putting X is equal to 0, you will get the answer for potential. All right, let's move on to the last few concepts. Okay, now, great. Now, properties of conductor, very, very important. Everything which I am putting up on the slide should be known to you. I have explained each one of them. In fact, some of them I have even derived it in my regular sessions. Okay, so you can watch it in the Pathfinder, but let me give you a quick recap. Whenever you have a conductor, the charges will lie on the surface. It's a solid conductor. If you charge it, the charges will be on the outermost periphery. Reason is they will try to repel each other. They will try to move away from each other. So they will try to be as far away as possible by reaching on the surface. That's number one. The charges accumulated at the sharp edges, charges are accumulated more at the sharp edges or the bends. Okay, so this is very important. So if you have a curved object, let's say it's a curved object like this, more charges will be here and few charges will be here. That's very important. In fact, the surface charge density of anything is inversely proportional to R. R is the radius of curvature. This point is very much related to this point. This is not just for a sphere, it's for any object that if you have a curved object like this, and this is the radius over here, this is the radius over here. Okay, these are two different radiuses. Okay, here the charge density will be different. Here the charge density will be little bit less. In fact, that sigma is inversely proportional to R. Very, very important property. More the radius, less the sigma. Less the radius, sharp edge, more the sigma. That's how it works. It's inversely related to the radius of curvature. So radius of curvature is that radius of that imaginary sphere which one can think of over here. Okay, this is the radius of that imaginary sphere. Okay, when you connect two conductors, let's say I connect this conductor and this conductor, what will happen? The one which is at higher potential will start reducing its charge. The one which is at lower potential will start increasing its charge. And the charges will flow from high potential to low potential till the potentials will become equal. So the charges will flow till the potentials become equal and everything becomes at the same potential. This is very, very important. Okay, so remember this. Whenever you have a conductor, remember this field is 0 inside that conductor. And because the field is 0 inside the conductor, what will happen? All these points will become at the same potential. Same potential. Reason is the field is 0. Keep this in mind. Everywhere the field is 0, all the charges will cancel out all the fields, and you know the potential will be same everywhere. Keep this in mind. Okay, last thing. Okay, surface charge density, I think I've already told you, it's charge per unit area. That's standard. That's fine. There is nothing great about it. Some more properties are also there. Look at this. Electric field inside a conductor is 0. So inside a solid conductor, if you have a solid conductor, everywhere you will see the field will be 0. Very, very important property. If there is a cavity, see, this was a solid conductor only. If there is a cavity, then there is a possibility of charge. There is a possibility of charge. When is there a possibility of charge? Look at this. If you have a charge inside a cavity, this charge will create induced charges. It will create induced charges. In fact, it will be minus q. Okay, it will try to balance it out. It will try to balance it out. A negative charge will be created inside the surface if you place another charge inside the cavity. If this charge was not there, then these charges will also be not there. Okay, remember that. If this charge is not there, even these charges will not be there. Only the charges will remain on the outermost periphery. Keep this in mind. Last thing. The field lines are always perpendicular to the surface of the conductor. Like you can see, any shape, doesn't matter, be it spherical, square, rectangle, anything, the field lines are always perpendicular to the surface. Alright, chalo. Let's also see some more properties. When you connect two shells, two objects, I have told you, the entire solid will behave like one single thing. The potentials will become equal. Everywhere the potential is same. Everywhere. Okay, when you connect it with a wire. That's one property. And last thing, if you connect a conductor to earth, what will happen? What will happen if you connect a conductor to earth? Then the potential will become zero. It will go to ground. Grounding means you're making sure that the charges will flow in or out somehow to make sure that the potential will become zero. Correct. These are the important properties which you should know for the conductor. Alright, chalo. Let's start doing some questions. What about this question coming up on your screen, guys? What do you say? When two charge conductors are connected, then what do you think is the a loss in energy? Will there be loss in energy? Yes or no? Come on, think about this. When two charge conductors are connected, then will there be loss in potential energy? Yes or no? Yep. Symbol for what, Vishnu? Potential is V. Yep. So yes, there is loss in energy. The reason is when you take conductor 1 and conductor 2 and you connect them, then the charge will flow. And the moment the charge will flow, okay, it will try to lower the potential energy of the system. So the moment there is flow, understand there is heat which is generated. So there will be heat which is generated. This heat will come from the loss of potential energy. Yes, there will be a loss of energy because whenever current flows, I squared R, heat will be generated because of that current. Keep this in mind. Next question. This is very direct. Very direct. Okay, come on my warriors. Two spheres of radius R1 and R2 are joined by a fine wire and they are raised to potential V. Okay, two spheres of radius R1 and R2 are joined by some wire and they are taken to a potential V. Now, if they are connected, obviously, the surface charge density are sigma 1 and sigma 2. What is the ratio of sigma 2 by sigma 1? This is very, very easy. Very, very easy. But many people might make a mistake. Is it R1 by R2? Is it R2 by R1? Is it 1? Is it R2 by R1 whole square? Interesting question, guys, coming up on your screen. If I take two shells and connect it and I find that, you know, this is sigma 1, this is sigma 2, this is R1 and this is R2. What do you think will be the ratio of sigma 2 by sigma 1? Okay, so I just told you, whenever you connect two conductors, it behaves like one single conductor. This is one single conductor. And I have just told you guys that the surface charge density is inversely proportional to R, radius of curvature. Radius is less, sigma is more. Radius is more, sigma is less. So sigma 2 by sigma 1 will be R1 by R2. Keep this in mind. Not R2 by R1. Be careful. It is sigma 2 by sigma 1. So that's why it will be R1 by R2. Okay. Yep. So that's how it is. It is inversely related to the radius of curvature. Yes. Correcto. Next question coming up on your screen. These are some points. This is a solid block. There is a cavity which is carved out. So let me just show this to you in case you are not able to see. This is some cavity inside that conductor. Okay. So this is a solid block. The question is on the fields, potentials, etc. at different points. Let's see if you can get this. This is not that tough. If you know the properties of the conductor, you will get it immediately. Come on, my warriors, you can do this. Figure this out. Okay, at point A and B, this is a charge which is placed. Okay, this is an extra charge. You remember what happens when you place some charge inside a conductor which has some cavity, it creates some induced charges, right? Definitely it will create some induced charges. So what will happen because of that? Think about it. Okay, yeah, so the field near A in the cavity is equal to electric field near B. Well, you can see the cavity is not circular, it is elliptical. So because of that, if let's say this was plus Q, obviously there will be charges, more charges developed over here, okay, and less charges developed over here where the radius of curvature is less. Why is the density different? Because wherever it is sharp, more charge. Wherever it is less sharp or it is blunt, the surface charge density is less. Remember, it is inversely related. So you can clearly see over here, the field lines are not, same. Here the field lines will be more because of more charges. Here the field lines will be less. Here the field lines will be less, clearly. So the field at A and B are same, that is wrong. Charge density at A and B are same, that is also wrong. Potential at A is equal to potential at B, that is correct because both are inside the conductor. This point are a part of the same conductor. In fact, if there was one more point, that point also will have the same potential. Okay, so that is definitely correct because they are a part of the conductor itself. Very, very interesting. Total field flux through the surface of the cavity is Q by epsilon naught. That is very obvious. So if I draw a surface, okay, through the cavity like this, what is the enclosed charge? The enclosed charge is Q. So if Q is the enclosed charge by Gauss's law, so using Gauss law, you will easily get this. So using Gauss's law, the flux through the total surface is enclosed charge by epsilon naught. As simple as that. Yes, answer is C and D. Proud of you, Vaishnavi. Very good, Vishnu. I think you got it eventually. Very good, Uma. I think you got it finally. Yep, Janish. D was there, but even C was there. All right, that's the answer. Okay. Next question, again multiple correct. For a charged conductor, which statement is wrong? If you have a charged conductor, one of the statement is wrong. Electric lines of force is perpendicular to the surface. Electric field inside the surface is always zero. Electric field is discontinuous at the surface. No charge exists on the outer surface of a conductor. Okay, let's see this one by one. Come on, my warriors. Electric line of force is perpendicular to the surface. So let's say I take a conductor, okay, over here, and I take another conductor over here. Okay, this is a cavity. So I'll just show. Let me take as many cases as possible so that if it is true for all the cases, only then I can mark it as true. Even if I get one case where it is not true, then it will be false. Okay, this is the solid part of a conductor. Okay, cool. Now if you draw the field lines, okay, it will come like this. Okay, so the field lines are always perpendicular, we all know that, and this is how it looks like. Okay, interesting. This is a cavity. Electric field lines are perpendicular to the surface. Obviously this option A is correct, no doubt about it. Okay, this is correct, but the question is which of the following are wrong. So first let's mark which are correct and then we'll mark which ones are wrong. Okay, cool. Electric field inside the surface is always zero. Now look at this. This is a surface. Okay, this is a surface, and if I go inside of it, okay, it is zero. Electric field everywhere is zero. Here if I go inside the surface, again it is zero, and here again if I go inside of this surface, also it is zero. Everywhere in this yellow shaded part it is zero. So hence this option is also correct. I hope this is clear. Electric field inside the surface is always zero. Okay. Electric field is discontinuous at the surface. That also makes sense. Look at that. The field is zero. Suddenly it gets a value. Zero, sudden value. So it was zero and sudden jump in the field. So it is discontinuous. There is a sudden jump. So this is a sudden jump over here from the, from the inside to the outside part. So it is discontinuous. That is also correct. No charge exists on the outer surface of the conductor. Well, that is wrong. We have just seen that all the charges will reside on the outer surface. No charge resides. That is definitely wrong. So the only wrong statement is option D. Yep. Vishnu, you should make notes probably later on. If you want to concentrate on the class, maybe you can do that right now. Yep. So guys, yep. So I hope you understood it, guys. Is it clear? Yeah. Okay, cool. Let's move on to the last few questions coming up on your screen. Okay. Chalo. Now, a conducting shell S1 having charge Q is surrounded by uncharged conducting spherical shell S2. The potential difference between them is V. Now, if you give the outer shell some charge, what is the new potential difference? Beautiful question, guys. Let's see if you can solve this. So there are two shells. Okay, let me mark this shell as S1. Let me mark this shell as S2. Okay, and let the potential difference between them is V. Now Q charge is given to the inner shell. That's what is given. Okay, so Q charge is given to the inner shell. So this is Q charge. Now when you add minus 3Q charge on the outer shell, what will be the new potential difference is the question. Okay, chalo, let's get going. Okay. Okay, come on my warriors, what do you think is the answer? Is it 1V, 2V, 4V or 2V? Think carefully. Yep, come on my warriors. Hello Harish, welcome aboard. So if you add, Harish is saying 2V, I'll tell you what. When you add negative charges, will it create a field inside? Will there be field because of the negative charges inside? So the field due to negative charges inside S2 will be in fact 0. Everywhere it will be 0. Okay, hold on Vishnu, I'm just talking about it. So there were positive charges initially. Now you have added more negative charges on the outside. When you add those negative charges, because of the negative charges, the field inside will be 0. We always know that. Field inside a shell due to a charged shell is always 0 inside. Outside, yes, there is. So if I know that these charges were creating some field before this, if these charges were creating some field before this, will this field change by the addition of the negative charge? Will this field change because of these additional negative charges? Think about it. Obviously, the contribution. So the contribution of the outside charges. So the contribution in field is 0. That means this field over here remains same. Everybody getting it? The field does not get affected by those outside charges. Hence, if field remains same, the distance between them remains the same, what will happen next? The potential difference will also be the same. Because remember, field always travels from high potential to low potential. High potential to low potential. So it should be the same, hence it will not change, it will be V only. So, the potential difference, delta V, will be same because the field is same, distance is same, so voltage difference will be same. Hence the answer is not C, it is A bacha log. Be careful, it's not C. Okay, is it clear? Shall we go ahead? This is such a brilliant question, amazing question, guys. A lot of people make mistakes. Okay, chalo, let's get going. Last question coming up on your screen now. Hello Ravi, very good Vaishnavi. Last question. Uma, what has just happened is because field is same, that's why potential difference is same. See, when you add more charges outside, nothing will happen. The field will still remain the same. So if E is same, we all know this, E is del V by del R. So del R is same, so del V is also same, as simple as that. So addition, this is by Gauss's law. Uma, you should watch the previous part. I hope you watched the starting part of my class today. I have given field due to all the geometries inside and outside. So I have clearly mentioned over there that whenever you are inside a shell, the field will be 0. Okay, so that's the reason. It also comes by Gauss's law. If you take a Gaussian surface, okay, inside a shell, the flux will be 0, field will be 0, charge will be 0. Yep. Okay, that's how it is. Okay, let's see how many of you can do this question. There are 3 sheets, and due to all the sheets, there will be some field at this point. What is the net field at this point? That's the question. That is k cap, this is minus k cap. Well, that should be straightforward. First of all, due to this positive charge, this is positive charge, the field will be outwards. So the field will go down like this because of that. Okay, it will be outwards like this. Now because of these negative charges, this negative charge, it will be pulling it inwards. So the field will be like this, correct, because of this negative charge. And lastly, due to this negative charge also, the fields will be like this. Uniform fields are created by charged sheets, one over the other. There are charged sheets. Think what will happen. This is the hint. Now you should be able to do it. Come on, my warriors. Use the formula for charged sheets, you will get it. Come on. Okay, 4 weeks. Anish, I'm not teaching right now in the batches which are going on, but I'm teaching in the micro courses. So you can find my micro courses, plus I'm launching a micro course in few weeks. You will be able to join my live classes there. Okay, Sahil sir is also good. Every teacher in Vedantu is good. Just have faith. Okay, don't worry about I want that teacher, I want this teacher. Don't fall into that trap. All the teachers are good, trust me on that. Okay, chalo, let's get going. Sapsi, put up all your doubts regarding 2021 in the comment section after the video ends. I'll definitely answer that. Now, here is the logic behind this. Because of this positive charge, the field is down. Because of this negative charge also, the field is down. And because of this negative charge also, the field is down. So all the fields are going to add. All right, so hence the net field will be equal to the field due to this positive charge downwards will be minus sigma by 2 epsilon naught k cap, because it's downwards. Because of this negative charge, again it is downwards, so it will be minus 2 sigma by 2 epsilon naught. Okay, lastly, because of this negative charge, again at this point it is downwards, so it will be minus sigma by 2 epsilon naught. Everywhere it is k cap. Okay, it is k cap over here as well. So what will be the final answer? Minus 1, minus 2, minus 1, it's minus 4. Minus 4 by 2, that's minus 2. Hence the final answer will be minus 2 sigma k hat divided by just epsilon naught, which is option C, I believe. Yep. Is that clear? No, it's not A. Oh, be careful. 4 by 2. Yeah. So be careful, guys. There will be 4 and 2. So 2 and 4 will cancel. Okay. And you'll just get 2. So that's why that 2 has come. Be careful. Okay. That's how you get it. Devi, physics is very easy. If you learn it properly, if you understand it, and if you solve problems. If you just read it, and if you don't learn it properly, and if you don't take interest in it, yes, it's very difficult. Okay, any subject, it not just for physics, everything, it's true for everything. Now, the reason why we should talk about VIP is because Vedantu is the only institute, online or offline, in India, which gives you the promise of guaranteed rank improvement. And if you do not improve in your performance while you join Vedantu and before you leave Vedantu, then the whole money will be refunded back to you. This confidence comes because we have excellent teachers, excellent coaching material, the tests, the assignments, the live classes, the micro courses, the option for you guys to learn in Hindi or English, the personalized mentoring that you get, also parent-teacher sessions, the interventions that we give you from time to time, the strategy, the motivational sessions in our regular classes. They are all planned. It's all there. Not just that, when you join Vedantu, you automatically get all the free courses available at Vedantu, all the KVPY courses for free. You don't have to pay anything extra. CBSE also is covered in Vedantu. Be it Maharashtra board, yes, Maharashtra board is also there. So all the things under one roof, that happens, because of our amazing ecosystem that we have. The whole ecosystem, is being carefully handicrafted, I can say, by lot of hard work, by so many people who work tirelessly, behind the scenes, be it the tech team, be it the product team, be it, the content team, be it the master teachers. So that's why we are being able to produce these amazing results. Now, if you want to join my batches, my micro courses, so you have a lot of options. All these, packages will give you access to my courses and other teachers' courses, all the long-term batches, test series, everything is available. Whether you take light, classic or plus. The only difference is here and here. If you want the doubt solving on the app, where you want to ask any doubts at any time and you want to get instantaneous replies, you go for the classic. And if you want personal mentoring, you go for the plus version. Most of the students go for the classic version. Some students go for the plus version who require that personal guidance and attention. The batches, although it says 6th September, there is a batch starting on Monday again. So every Monday there is a batch starting. So guys, if you have missed out on good coaching, if you guys think probably the coaching that I have joined is not giving me enough attention, not giving me enough quality content, and I'm not happy with it, then try it out for 1 month, because there is a 50% offer which is running out. All the courses, it's a brief offer, it's a very short offer because of the Teachers' Day. So the course price usually was 3,000, so you will get 50% off. This is the old offer where you used to get 10% or 20% off. So right now you will see this. Okay, where is it? So let's go to home and let's go to my class right now. Okay, so this is the video that you're watching. So if you go down over here, you will see there is a KVPY crash course, 50% off. You'll get it only for 2,000 rupees. So the entire KVPY preparation for physics, chemistry, maths is done over here. But if you want the long-term batch, which also includes the KVPY course, my courses, tests, everything, this is where you click and you will get 50% off. Again, using my coupon code, 50% is off. You can see that. So it's only for 1,700 per month. That's very interesting. 1,700 per month is very, very cheap. Yeah. So guys, check it out. Yep. So I have a Telegram account, but I do not use Telegram. I use, you can leave all your doubts in the comment section or probably on Instagram, but Instagram is also very difficult for me to reply most of the times. Okay, so that's why I don't generally use my Telegram. And if you want to get in touch with me, my Instagram handle, as well as, you can leave a comment after the video ends. Good night. Thank you guys for tuning in. Do check this out, because the courses are going to start this Monday. I'm pretty sure you don't want to lose out on this offer, these courses, because you cannot just depend on YouTube. Let me tell you that. Yeah. All right. Take care, guys. Bye bye. Have a great time. See you in the next class again. Hasta la vista.